thing is you can go into the scan menu. It's so tiny, I can't really show you there, but so you've got a couple of settings you do, like for a project. You say what file name you want, you say what path you want to store that project in, and you want to give the project a name for the project file later to open. Project file is just a file which contains the links to all the scan files you acquired during the course of your project. So later you don't have to open every scan individually, you just open the one project and it will open all the scans. Most important here is the resolution, that's this little button here. So you've got various settings from preview to extremely high. You're not at ridiculously high yet, but maybe next version. So extremely high would be 6 millimeters over 100 meters, while the preview scan is about, I think, 5 centimeters on 10 meters. So it's pretty coarse resolution. Then we've got the quality setting. Now the quality is basically the speed with which you acquire each point. Now this is very important to understand, and if you compare scanners, you need to make sure you compare the accuracies at the same speed, measurement speed. Because you can imagine, let's say a scanner got 1 second to measure the distance to one point. It can measure that point thousands of times in that time, in that 1 second, and then just average it to the one measurement. Okay, so it's got quite a lot of time to measure one single point. Now if you've got an instrument which measures 1 million points per second, it's got much less time for the same point. So the noise in your measurement increases or decreases with the time you take, with the time you it scans. So we've got 4 settings there. One is called low, and we've got a premium setting on the other end. And it basically increases your scan time. One setting increases your scan time by double the time. So you start off, let's say, you start off at 1 minute, the next quality setting would be 2 minutes, 4 minutes, 8 minutes, something like that. Normally, our standard settings is a high resolution with normal quality. Normal quality is the second setting on the quality setting. That is about a resolution of 6 millimeters on 10 meters distance. The normal speed, I'm not sure how many points that acquires now, probably around 250,000 points per second. And the entire scan, just for the geometry, takes about 30 minutes and 20 seconds. Right? You can go to less quality or to a lower resolution to speed things up. The quickest scan is 25 seconds. But as soon, well, if you're scanning normal environments, excuse me, let's say up to 50-60 meters, the normal quality setting is completely fine. If you go beyond 70 meters, or if you've got very fine detail, you want to increase the quality setting, scan slower, so you've got less measurement noise, basically. Yeah, that's about that. You can activate if you should use that compensator inside, and you can then say here, that button down here, if you want the color to be switched on or off. That's it. You can also tell it to use the camera light. That happens all in that setting. But we didn't mount it now, so no point in doing that. And the second setting over here, that's activating the T-cam. So what we do now is we take geometry, imagery, and the thermal camera image. Okay, once I did all the settings, it can pretty much remain at this. All the project settings I did, well, you just stick to that during the course of your project. Well, the only thing you do is during, when you set up at different positions, is to change the resolution and maybe the speed and maybe the color. But normally you leave the color on and you leave the resolution the same. Unless, for example, you go into a small corner, let's say you scan, next position is under that table there. You don't need 6 millimeters over 10 meters, which means at 1 meter distance it's 0.6 millimeters resolution. you don't need that under the table. So there you would change the resolution and land up with a much, much quicker scan. Okay, I'll go to high and low quality now. That's a 1:40 scan. And just press the button for scanning. That's it. So now it starts. There's a little 0 indicator down here. It always starts at 0 and scans 180 degrees. 180 because you always scan a full profile, so it always scans both sides. You only need to rotate 180 degrees to get a 360 degree overview.
So what Christoph said with the density of points on the surface, normally it's not necessary to go below something like 3 or 4 millimeters spacing from one point to each other. Why so? I mean, for the geometry. Because the laser beam itself has a diameter of 3 millimeters, and if we go below these 3 millimeters, we overlay laser spots one to the other. Because out of this 3 millimeter diameter spot, we get one coordinate, which is the average of the centroid. Yeah? And if we go below these 3 millimeters, we have all these overlays in geometry. So this does not make sense from a geometrical point of view.
Do not gain more detail because you do that.
Yeah. Also, if there are cracks in the wall, like below 3 millimeters, the laser beam does not get inside these cracks. Yeah. It gets split.
You can probably see on the intensity that there is a crack, but you cannot acquire the geometry. It's even if you increase resolution.
It disturbs as a line, and you can maybe detect that there is a crack, but you cannot really measure it because it is a limit. PR is the limit of your technology.
So you get with the, if you look at the specs in the brochures, you can get sub-millimeter range. Take a 20 megapixel sensor where the pixel has to be much smaller than this chip. There's only little light for each pixel, so you're going to have a lot of noise in your data. That's what we want to avoid. Now what you just heard is the thermal camera, which has been activated and starts rotating now, taking thermal images.
It's much faster because of the low resolution.
And also less, only one exposure setting. There's not like 10, 11 at each individual position.
So in this case, it doesn't matter that the camera is not on the nodal point of the rotation?
Well, you get a little bit of parallax, but the thing is, well, it needs to sit somewhere. And the thermal image is lower resolution, so usually it's more about temperature differences than a very accurate temperature reading. It's also usually only a problem in, let's say, distance of 1 to 2 meters maybe. After that, the parallax effect is pretty much negligible.
But mainly because the pixels of the thermal camera are bigger. It's another resolution. Yes. And with the thermal camera, usually the information you are looking for is in the surfaces and not on sharp corners. The scanner describes you with high resolution the sharp corners, but the thermal image is like the temperature on the surface.
Okay, so that was a scan. Now what we can do, or what we need to do in the end is, after the project, to download the data somehow. You can do that in many ways. There's an Ethernet cable you can put in down there, which is the fastest. Or you can use the Wi-Fi on top, or you can just use a USB drive, put it in, and then you just go into the scan menu and copy it over. What I didn't show you yet, the is the results. Well, I'm showing it better on the screen, but just so you see it here. We've got a little, we call it an electronic field book. So after each scan position, you can roughly position your scan in relation to the previous scans. So at the end of the day, you see a little outline. We'll come closer in the break later. You see a little outline. After you did the entire project, you can see an outline of your object, of your site, and you know exactly where you scanned before. So let's say it's quite important if you scan, for example, a building, you start in the morning on the one side, you come around, and in the evening you're at the other side. Or you join the project together again. Now, you see a little detail somewhere, and you want to know, did I scan it? Do I have it on another scan? Do I need to reposition myself? So you look onto the map and you say, oh, hang on, no, I was positioned over there, from there I could see it. And that's why we thought it's quite good to have an electronic field book. Of course, you can do your own drawing, but then you have to carry it around all the time. It might get dirty, or it might get lost. Things like this happen. So that's why we introduced a little field book. You can download a satellite image and put it at the back of it. You can use a Google drawing as a reference as well if you want. And then the next setting is you get a preview of the scan you just did. You can zoom in. You can also do some measurements. So you pick a point and it will tell you what distance that is. That is quite important. For example, if you've got now some targets which are far away, you know that the resolution which you chose is maybe not sufficient, or you want to check if it was sufficient. So you pick the target here, and you see, oh, it was 50 meters away. I need higher resolution. So you pick. So the next thing is take the rectangular tool here and just mark a couple of areas, a couple of targets at the same time. It doesn't matter. And you press scan. And now you just set another resolution for those areas, and it will automatically in a batch process acquire all these little areas in a much, much higher resolution. So when you set that once, and it does that for you. Let's go back. Another thing you can do, you can pick 2 points and measure the distances between those 2 points, for example, if you need a quick measurement. Or you can, as I mentioned earlier, you can just pick a point and assign a label to it. So I take one, I don't know, pick one over there, label, just say test. Okay. And I'll show you the software how it's done. Okay. So you can, right after the scan, check what you saw. Do you see everything? Imagine that thing is now 1 meter higher. You cannot go there yourself and check what you can see, so it's quite important that you can check on the scanner what you scanned. Yeah. Okay, now just to transfer the data, you go.
Question. Can you check that on your Wi-Fi device if your scan is correct?
Yes.
Before you dismantle it?
The new scanner will allow you to download a preview image and also like move around in there, do markings, do measurements, things like that, and also set subscans and do that remotely.
So you don't need to touch the screen.
No, it's if you put it somewhere where you can't see the screen, that you can confirm if the measurement is correct before you review.
Yes, exactly. Even especially the applications that we've seen before, if you turn it around with the tripod and go into holes, you cannot arrive there to look on the screen or handle it. That's when wireless becomes very efficient to handle it. Yeah.
Okay. So now in the menu I've got my files on the scanner. I could select the entire project or just now the one file. Say copy, USB drive, and go. Takes a little bit. Of course, we're looking at like 300, 400 megs of data now.
So I think we go to the break now, while we download the data, and afterwards we see some data on the screen over here.